Hello students, welcome to the channel of Vedant classes. Okay, so today we will start with the class 11 physics, the basic concepts which are very important for the physics. Students usually didn't learn these topics well during their beginning of the science journey. So let's start with the few basic topics, that is slope and differentiation, in this lecture. Okay, so let's start with the slope. Okay, let's see the slope first. See, the notation for the slope is small m. Okay, how we can define the slope? Slope is tangent of angle formed by line with respect to positive x-axis. This is the very basic and basic definition for the slope. Okay, it is the tangent of angle formed by line with respect to positive x-axis. Let's say for an example, we are having the graph y versus x and line is passing like this. Okay, let's say this line makes an angle theta with the positive x-axis. Then we can say tangent of angle means it's tan theta, tangent of angle, and that is called slope. So we can write m is equal to tan theta. Now you can see over here, if we consider the point here, either here or here, okay, the angle will remain same. Okay, as the angle will remain same at all the points. So you can say that slope is constant in this case. Slope is constant in this case. Okay, now this graph is for straight line. Okay, here we have considered the straight line. Now let's consider a graph for any function which is not a straight line. Let's say any curve. Okay, for any function, let's say curve, any curve we are having. Consider the curve like this. Okay, now consider point here, here and here. Now if you find a slope over here, you just need to draw a tangent. Okay, let's say that is theta 1. For this it will be theta 2. For this it will be theta 3. You can see that here theta 3 is greater than theta 2 is greater than theta 1. Okay, so in general you can say as theta changes, it means that slope also changes. So in such case slope will become variable. Okay, so slope is variable for such kind of curve. So when the graph is not a straight line, okay, so you will get a variable slope in such cases. Now let's see the formula to find a slope. Formula to find slope using basic coordinate geometry, you can easily find out the formula for the slope. Let's consider a graph. Let's say here we are having a line. Okay, consider a point A whose coordinate is x1 y1 and here point B whose coordinate is x2 y2. Okay, let's make this line making angle theta with the positive x-axis. Okay, now just take out the projections, so you get a triangle over here. So this angle will also be theta. Now if you consider this, it will be y2, this will be y1, from here it will be x2 and this will be x1. You can clearly get this height will be y2 minus y1, this height will be y2 minus y1. Okay, and see this one will be x2 minus x1. Okay, Now what is slope? Slope, that m means tan theta, and tan theta is opposite upon adjacent, or you can also say it's perpendicular to base. So what is perpendicular? It is y2 minus y1. It is y2 minus y1, and here the base is x2 minus x1. So this is the basic formula for the slope. So in general you can say that m is equal to tan theta, which is equal to y2 minus y1 upon x2 minus x1. What is y2 minus y1? You can call it as change in y upon change in x, and using symbol you can use it like this, delta y by delta x. So in general you can remember this concept of slope like this. Okay, this here the symbol is called delta, which represents change. Okay, symbol for the change is delta. We use delta in physics for the change. Okay, so what the concept is? Concept is, it means that rate of change of y with respect to x. This simply means this one, rate of change of y with respect to x, and that will give us the value of slope. Okay, now see, we considered the line to calculate the formula of slope. We have taken line, which is a linear function, and we have seen for the line the slope is constant. Slope is constant for the line. Okay, so we considered this one to calculate the formula of slope. Okay, and we got this conclusion. Okay, we got this concept that change of y with respect to it, you can just write it as change in y with respect to change in x. Okay, now let's see the differentiation. What is differentiation means? Okay, let's give the heading. Differentiation. Okay, now let's write the definition of differentiation. Okay. Process of finding the rate of change of one variable with respect to another variable for a given function. Now say in the case of slope we are having a linear function, and here it is given that it's for any given function. So function can be either of two types, whether it is linear or non-linear. Okay, so non-linear means it's not a straight line. The graph will not be a straight line, and we are having a slope as variable. So it means that differentiation gives us the slope at any point of the graph. So differentiation helps us to find the slope at any point of the graph of a non-linear function. So this is the basic concept for the differentiation. It might seem typical, but let's see a concept in detail. Okay, so let's check its concept, how to find the differentiation. Okay, now let's consider a graph. We'll consider the same curve. Okay. Now we need to calculate the slope between these 2 points. Let's say A x1 comma y1 and it's B x2 comma y2. Okay. We need to find out the slope between these 2 points. Okay, now let's draw a tangent for the point A. So it will be like this if it's making an angle theta over here. Now we can see that is simply not covering this portion. Okay, so we are not able to find out the slope for this type of curve. Okay, so it's not possible to find slope between point A and B. Okay, so we fail to find the slope between point A and B in these two cases. Okay, okay, so now what we can do, take A and B very close to each other. Now considering point A and B close to each other, okay, now let's say point A is here and point B is here. Okay, we are having the coordinate x1 y1 and b x2 y2. Now if we draw a slope, okay, if we draw a tangent, then we are getting a small triangle over here. Okay, we are getting a small triangle. Now let's see this triangle, how it seems. It will be like this. Okay, so it's point A and it's point B. Now here you can see that the difference between the value of y2 minus y1 is approximately near to 0, and x2 minus x1 is also somewhat near 0, because these 2 points are so small, okay, so near. So the difference between these 2 points is very small, and it is near to 0 somewhere. So we can technically write this one as y2 minus y1 0 and x2 minus x1 0. Okay, and this symbol means it's tends to, it's read as tends to 0. Okay, so mathematically we can write it as, when limit of delta x tends to 0 for change in y to change in x, it will be written as dy by dx. Okay, so here d stands for very small change. Okay, the delta stands for the change and d stands for when the change is very small. Okay, technically it is called infinitesimal difference, means very small change. Okay, so this simply means the rate of change of y with respect to x is small. Okay, so this is the concept of differentiation. Okay, it is rate of change of y with respect to x. Okay, so now let's mention few important points. Okay, so now see, as A and B are very close, we will get slope of function at one particular point. Okay, now see, as A and B are very close to each other, we can consider it as a given point. So that's what we have written. The differentiation gives us a slope at any point of the graph of a nonlinear function. So this is how we can calculate the value of slope and that's called a differentiation actually. Okay, so in physics, where the differentiation is used, differentiation is used to find instantaneous values. Okay, in physics, differentiation is used to calculate the instantaneous values. Okay, so that's all from this lecture. I hope you have, now we are clear with the slope and differentiation, you get the clear idea regarding that. Okay, so if you are really finding it helpful, please like, subscribe and share it with your friends, those who need to understand these topics. Okay, so stay tuned with the lessons. Okay, thanks a lot.